The next thing is the inverse of a 3 by 3 matrix. So we'll start with a definition. The transpose of a matrix A, denoted AT, or sometimes some people write AT like this, or some people even write this, is the matrix A with the rows and columns interchanged. So, for example, if we consider A is the matrix 1, 2, 3, 4, 5, 6, the transpose of A, we swap the rows and columns, so it becomes the matrix 1, 2, 3, 4, 5, 6, like this. And similarly, if we have B is 0, pi, 2, 3, then B transpose is 0, 2, pi 3. You just swap the rows and columns. Whatever was the first row becomes the first column, and so on. So that's the transpose of a matrix, which we're going to need in the process for finding a 3 by 3 inverse. So steps for finding inverse of 3 by 3 matrix A. Number 1, find the determinant of A. So we did that, I think, 2 lessons ago. Number 2, find the matrix of minors of A. And remember, so if A is A, B, C, D, E, F, G, H, J, then the matrix of minors is, it's a 3 by 3 matrix. The first entry, the minor of A, is the determinant of the 2 by 2 submatrix we get when we cross out the row and column containing A. So that's the first entry, that's the first minor, that's the minor corresponding to A. The minor corresponding to B is the determinant of AC, DF, GJ. The minor corresponding to C is the determinant DEGH. The minor corresponding to D is BCHJ. The minor corresponding to E is ACGJ. The minor corresponding to F is determinant ABGH. And lastly, the minors corresponding to GH and J, I'll just write them down. Okay, so we have this 3 by 3 matrix of the 9 minors, which I'm now going to use different notation for that's just going to be easier. If I rename these M1 up to M9, that will just make things easier for us now. And then step 3 is find the matrix of cofactors. Cofactors are just minors adjusted. So this is the minors adjusted using the plus minus plus thing again. So the matrix of cofactors, which we'll call C, is M1, and then M2 we're going to replace with minus M2 because there's a minus here. M3, and then minus M4, plus M5, minus M6, M7, minus M8, M9. And then, last but not least, step 4, A inverse is 1 over the determinant of A times the matrix of cofactors transpose. So the transpose, you just swap the rows and columns. So we get M1 minus M2, M3 is the first column, minus M4, M5, minus M6 is the second column, and so on. So this, So there's quite a lot going on here. There's a lot to do if you need to find the inverse of a 3 by 3 matrix. So if you like the upshot, the good news is your calculator can do it if the entries are all given numbers. So if there's nothing in terms of k or in terms of another unknown, you just plug it in your calculator. If, however, you have something that has an algebraic unknown in it, you have to do this process. So we'll see once. Oh, by the way, if you're using your calculator, I think there's a mat button somewhere. You have to do mat A inverse, something like that. So we'll see we'll do two examples. One with a matrix where all the entries are numbers. So if we have A is 1, 3, 1, 0, 4, 1, 2, minus 1, 0. And the question is find A inverse. So let's see. Step 1, that was find the determinant. So all we're going to do is what we did before. Pick a row or column, preferably involving a 0. So here we could pick the second row. And then the 0 gives us nothing. The 4, that goes with a plus. So we get plus 4 times the minor, 1, 1, 2, 0. And then minus 1 times the minor, 1, 3, 2, minus 1. So that's 4 times minus 2 minus 1 minus 6. So that's minus 8 plus 7, which is minus 1. Okay, step 2, that's find the matrix of minors, M. So the first minor is the determinant of 4, 1, minus 1, 0. The next one is the determinant of 0, 1, 2, 0. The next one is the determinant of 0, 4, 2, minus 1. And so on. There are a lot to write down. I won't write them all down as determinants like this. A good thing to try and do if you have to do this, is work them out as you're going along. So instead of writing everything down, just write down what the answer is to this one. So this we can see is 1, isn't it? And the next one is minus 2. And the next one is minus 8. And then in the second row, the minor corresponding to the 0 is 1. And then the middle, the minor corresponding to 4 is minus 2. And then the minor corresponding to this 1 in the second row is minus 1, minus 6, that's minus 7. And then the minor corresponding to the 2 is 3 minus 4, which is minus 1. The minor corresponding to the minus 1 is 1. And the minor corresponding to 0 here is 4. So that's the matrix of minors. And then we can, step 3, work out the matrix of cofactors. So all we do is adjust this using the plus minus plus. So this changes to plus 2. This changes to minus 1. Minus 2 stays the same. The minus 7 becomes a plus 7. This 1 in the middle becomes a minus 1. So that's C. And then step 4, A inverse is 1 over the determinant, which we found was minus 1, times C transpose. So that's minus. And then C transpose, we swap the rows and columns. And then we negate all the entries because we have a minus at the front from the determinant being negative. So we get minus 1, 1, 1, minus 2, 2, 1, 8, minus 7, minus 4, and that is the correct answer. So your calculator can do that. But if one of the entries was an X, for example, you would have to go through this process. So we'll now just see one example where there's an algebraic unknown. So now we're given a matrix B, which is 3, 2, minus 2, k, 0, minus 1, minus 3, 3. And we're told k is not 0. because that would make the determinant 0. And the question is find B inverse. Okay, so same steps as before. Determinant of B. Good to pick a row or column that has 0. So again, we could pick the second row or the third column. So let's pick the second row again. So we've got minus, if you think about the plus minus plus again, we've got a minus going with the -2. So it's minus -2 or plus 2 times the minor corresponding to -2, which is 2 minus 2 minus 3, 3. Plus k times the minor corresponding to k, which is this, plus 0. And that is 2 lots of 6 minus 6 is 0, plus k times 9 minus 2. So we get the determinant is nothing more than 7k. Next step, step 2, we need to find the matrix of minors. So the matrix of minors M, and I don't want to write down every single minor as a determinant. So let's try and do it as much as we can in our heads. The minor corresponding to the top left 3 is just going to be 3k, because it's the determinant of this submatrix here. So this entry is 3k, just here. The one corresponding to 2, that's -2, 0, -1, 3, that's -6. The minor for the top right is going to be 6 add k. The minor for the -2 over here is going to be 2 times 3 minus -2 times -3, that's 0. We found that, didn't we, here? And we found the one corresponding to k was 7 as well. And then the minor corresponding to 0 is 3 times -3, add 2. So that's -7. And then for the bottom left entry, the minor is 2k. For the middle bottom entry, the minor is -4. And bottom right, we get the determinant of the top left 2x2 submatrix, which is 3k plus 4. Okay, so that's the matrix of minors. So the next step is to find the matrix of cofactors. So to do that, we need to use the plus minus plus to change negate these 4 entries. So we're going to get 3k, 6, 6 plus k, 0, 7, 7, 2k, 4, 3k plus 4. That looks good. And then the last step, it was B, wasn't it? Not A. So B inverse is 1 over the determinant of B, which was 7k. So 1 over all of 7k times C transpose. So that's 1 over 7k times C with the rows and columns interchanged. So we get 3k, 6, k plus 6, 0, 7, 7, 2k, 4, 3k plus 4. And then we just need to divide everything by 7k. If you want, you can put that inside the matrix. And we get 3/7, 0, 2/7, 6 over all of 7k, 1 over k, 4 over 7k. In fact, it was probably nicer to leave it outside, but since I've started doing it, we'll just finish it off. K plus 6 over 7k, 1 over k, 3k plus 4 over 7k. Yeah, so this last step I did isn't completely necessary, but just writes it all inside the matrix. And this is the answer. So your calculator can't give you this because of the k's. So in the exam, they do like to ask questions like this, where you're forced to use this long procedure because you're not given something your calculator can do. And next time we'll see how, well, really the power of the inverse matrix and how we can use it to solve simultaneous equations, especially in the 3x3 case. But note for larger square matrices, for example, if you had a 4x4 matrices, the procedure is virtually identical to this. You do exactly the same thing to find the determinant, and the procedure for the inverse is the same. The only difference, really, is that your plus minus plus diagram is a bit more complicated. Instead, the pattern you use is this. But you can easily see how to extend this to even higher dimensions as well. If we had next, we'd just continue the same pattern for 5x5, 6x6, and so on. So really finding the inverse of matrices takes a long time if you do this procedure, but the procedure itself is just an algorithm that a computer can be programmed to carry out. So yeah, so that concludes inverse of 3x3 matrices.